Okay, so you asked how to convert the acetal form to the carbonyl form, following up from what your last question was. Um, I'm sorry I didn't answer that in that video, but I'll get to that here. So basically, what I like to memorize, the mechanism to between converting them is kind of confusing, but what I like to memorize is that this carbon right here, this carbon that's attached to two oxygens, is going to be the carbonyl carbon in your product. So since your product is a carbonyl, this carbon attached to two oxygens will be the carbonyl carbon. And basically what happens to these two oxygens is that in our product, they pop off and form alcohols. So basically this molecule splits apart into one a carbonyl and two an alcohol. So deciding what type of carbonyl it's going to be, if the carbon that's connected to two oxygens right here is, since this is going to be our carbonyl carbon in our product, if it's attached to two carbons, like here it's attached to one CH3 on the right and one CH3 on the left, this is going to be a ketone in our product. So as we add acid and water, this is going to be our ketone, and the two oxygens pop off and form alcohols. On the other hand, if our carbonyl carbon is attached to one carbon and one hydrogen, this is going to be an aldehyde in our product, since carbonyl carbons for aldehydes are attached to one carbon and one hydrogen. Same here. So that's what would happen there. And if your carbonyl carbon is attached to two hydrogens, which this isn't in the problem you showed me, but they could give you an exam question like this, it's actually going to be formaldehyde in your product, which is basically a carbonyl with two hydrogens at the ends of them. So let's go back and look at your question. So as we added H plus and H2O, we want to convert from the acetal form to the carbonyl form. Now we need to look at our carbonyl carbon, how many carbons and hydrogens it's attached to. So here, this is the only carbon that's attached to two oxygens. It's attached to one carbon and one hydrogen. So in our product, it's going to be an aldehyde, because here you can see it's attached to one carbon, which was this carbon, and it's also attached to a hydrogen. Here, this is going to be our carbonyl carbon. It's the only carbon attached to two oxygens. It's attached to one carbon going up here, and it's also attached to one hydrogen, since carbons have to have 4 bonds, 1, 2, 3, 4. So in our product, it's going to be an aldehyde because it's attached to one carbon and one hydrogen, which, remember, the oxygens are just going to pop off and form alcohols. So this ring is going to split apart, which here these split apart as well, and this split apart to a different molecule because it's not attached to our ring directly in our product. Versus here, in question number 3, this is going to be our carbonyl carbon. It's the only carbon attached to two oxygens. Other than the oxygens, it's attached to two carbons, one here and one here. So in our product, this carbonyl carbon is also attached to two carbons. It's just going to be a ketone. And these oxygens pop off, forming alcohols. Since it's not attached to the ring in our product, it's going to be a separate molecule. So yeah, I hope that answered your question.